All right, this lesson is on simplifying complex rational expressions. So we're going to start off with just simplifying some fractions where we divide 3/5. And then we change to multiplication, and then we flip that second fraction. Now we go ahead and multiply across. So 3 times 2 is 6, and then 5 times 1 is 5. The second one here, we keep the 2/3. We change this division symbol to multiplication, and then we flip the second fraction. And then we multiply across. So 2 times 2 is 4, and then 3 times 3 is 9. Again, we keep, change, flip. Now, some rational expressions are what we call complex. A complex fraction contains one or two fractions in its numerator, in its denominator, or both. Here are some examples. So here is a fraction in the denominator. Here is a fraction in the numerator. And then this has a fraction in the numerator and the denominator. So recall that the bar in a fraction represents division. Therefore, you can rewrite a complex fraction as a division problem and then simplify. You can also simplify complex fractions by using the LCD of the fractions in the numerator and the denominator. So here's our first example. We're going to go ahead and keep the first fraction. And then this is our division symbol. So we're going to change that to multiplication. And then we're going to flip the second fraction. And now we can go ahead and multiply across. So I'm going to just go ahead and put parentheses. Now we multiply across. So we're going to FOIL. So first, outside, inside, last. So we get x squared plus 5x plus 2x plus 10. And then in the denominator, we do the same thing. So first, outside, inside, last. So we get x squared minus 3x minus 1x plus 3. When we combine any like terms, so in the numerator we have x squared, these are alike, 7x plus 10, and then in the denominator, x squared, these are alike, so minus 4x plus 3. Then we look for any values that makes it undefined, so we're going to go up to here. We do not want that denominator to be undefined, so we say x cannot be 1. This one here, we do not want it to be positive 3, and then minus 5. All right, here's our second example. We're going to keep x plus 1 over x squared minus 1. Then I'm going to change this to multiplication and then flip the second fraction. And then we multiply across. So before we multiply across, we have a factoring we can do in the first fraction's denominator. We can factor that by the difference of two squareds. So we have x plus 1 and then x minus 1. Second fraction just stays as x minus 1 over x. So now we cancel any common factors. We have an x plus 1 and an x plus 1. We have an x minus 1 and an x minus 1. So what's left in the numerator is the number 1, in the denominator, x. Then we look for any domain restrictions. What can x not be? So up here, or down there, we do not want it to be 1 or negative 1. We do not want it to be 0, and we do not want it to be 1. All right, here's another one. What's different about this is up in the numerator we have two fractions. So we're going to do this one a little different. We're going to find the LCD of all of the denominators. So here's our first denominator of x, this denominator of 4, and this denominator of x. So we're looking for the least common denominator of these three terms. So the LCD is going to be 4x. So what we do is we multiply all of the terms by 4x. So here's our first fraction. We're going to multiply that by 4x. Then our second fraction, we multiply it by 4x. Then we have our denominator here, x plus 1, and we multiply it by 4x. So all three fractions we multiply by the LCD. Now what's cool is we can start canceling any common factors. So in the red, we have a common factor of x. In the purple, we have a common factor of 4. And in the green, we have a common factor of an x. So let's see what's left. So in the red, we have 2 times 4, which is 8. In the purple, we have an x times an x, or x squared. In the denominator, we have a 4 times an x plus 1. And then we're going to go ahead and simplify this. So I'm just going to rearrange the order of the terms in the numerator, put in standard form, so it's x squared plus 8. And then in the denominator, I'm going to distribute that 4, so I have 4x plus 4. And then our domain restriction, we do not want x to be 0. And then here's the other one. We don't want it to be negative 1.